I have spent pretty much my whole morning buried in this fascinating stack of astrophysics journals. And honestly, it has completely flipped my whole perspective on the cosmos.
Oh, I can imagine. It's a deep rabbit hole to go down.
It really is. So today we're doing a deep dive into what the research calls the Symphony of Silence. The whole idea is to understand how we're moving past just looking at the universe and starting to actually, listen to it.
It's a fundamental shift, really. We're moving from like a silent movie era of astronomy into full surround sound.
Okay, but let's tackle the big one first, that old tagline. In space, no one can hear you scream.
Right.
We all know space is a vacuum. I mean, my physics teacher hammered that home. Sound needs air. So, is physics wrong?
No, physics is safe. You're absolutely right. Your voice wouldn't travel if we were, floating out there. But the thing is, while there's no air, the universe itself is vibrant. It's full of these oscillations.
Oscillations.
Yeah, ripples in space-time, electromagnetic fluctuations, plasma waves. It isn't silence, it's a set of frequencies we haven't had the ears to hear until now.
Right. And the loudest instruments in this cosmic orchestra seem to be gravitational waves. These are literal ripples in the fabric of reality. Is that right?
That is the core of it, yeah. When you have these massive objects moving asymmetrically, like two black holes spiraling into each other, they generate these waves. They actually stretch and squeeze space itself as they pass by.
And when we say stretch, I mean, the scale is just absurd. I read they change distances on Earth by less than the width of a proton.
A proton. It's almost unimaginably small. Imperceptible to us.
Wow.
But it travels at the speed of light. It's this rhythmic distortion of the entire universe.
Okay, but here's the part in the research that really got me. This idea of an acoustic blueprint from the Big Bang. It suggests the early universe actually did have sound. How's that possible?
Because back then, it wasn't a vacuum. Not at all. About 380,000 years after the Big Bang, the universe was incredibly dense. It was this hot, thick, soup.
A soup.
A photon baryon fluid is the technical term. Light and matter were all trapped together.
So it's thick enough to carry, actual pressure waves.
Oh, it was roaring. The pressure waves were immense. And the fascinating part is, as the universe expanded and cooled, those waves got sort of frozen in time.
Frozen.
We can still see them. They're imprinted on the cosmic microwave background. We call them acoustic peaks.
And measuring these peaks tells us the universe is spatially flat. I hear that term a lot, but why should I care if it's flat?
Because that shape, it basically determines our destiny.
Our destiny.
Since we know it's flat, we know it's not going to stop and crunch back in on itself in a big crunch.
Ah.
Instead, it suggests the universe will likely just keep expanding forever. It changes the entire timeline of existence.
That is huge. That's a future of endless possibility instead of a fiery dead end. It's amazing you can pull that much meaning out of faint signals. It's really a game of separating the signal from the noise.
That's the challenge in astrophysics and, honestly, in just about everything else.
Yeah, you're right about that. Which is actually a perfect segue to our sponsor, Embersilk. We'll deal with noise, right? Data overload, messy workflows. Embersilk helps you find the signal. They specialize in AI training, automation, and software development.
Right, so it's all about figuring out where these new AI agents can actually make an impact for your business or even your personal life instead of just, using tech for tech's sake.
Exactly. If you want to streamline your world, you should check them out at embersilk.com. Okay, back to listening to space.
Yeah.
The ears we use. I was reading about LIGO. That's the Laser Interferometer Gravitational Wave Observatory. The engineering is just wild.
It's incredible.
They split a laser down 2 massive tunnels, right?
2 arms, yeah. 4 kilometers long each.
And the idea is a gravitational wave hits, stretches one arm just a tiny bit.
A tiny, tiny bit.
And the lasers don't match up perfectly when they come back together. That mismatch, that interference, that's the signal.
You've got it. That's exactly it. That mismatch creates a signal. And when black holes merge, the frequency rises really fast, creating the sound we call a chirp.
But that's the high-pitched stuff. For the deep bass notes, the sources talked about pulsar timing arrays. This seemed even more sci-fi, using stars as clocks.
It's brilliant, isn't it? We monitor these millisecond pulsars, which spin with this incredible regularity. If a massive gravitational wave, maybe from two supermassive black holes merging, passes through the galaxy,
It messes with the timing.
ever so slightly, it changes the timing of those pulses. It's like hearing this very, very low background hum across the cosmos.
And we can actually listen to this. I've heard the clips. Sonification, that's what it's called.
Sonification, yeah.
Yeah.
We map the data to a pitch that human ears can process.
And it's not just for art, right?
Oh, no, it's a powerful analysis tool. The human ear is an amazing pattern recognition machine. We can sometimes hear an anomaly, like that chirp, faster than we can spot it on a graph.
It just makes the universe feel so much more dynamic.
Hmm.
And the next step is LISA, the space-based detector.
LISA is going to be a complete game changer. Imagine a detector floating in space, but with arms that are millions kilometers long.
Wow.
It'll let us listen deep into galactic centers, hear things we could never capture from the ground. We're essentially learning to read the full musical score of the cosmos.
I love that. The universe isn't some static painting, it's a song.
Yeah.
And we're just now learning the lyrics.
And the more we listen, the more harmony we seem to find.
That is a perfect place to leave it. We aren't just observers anymore. We're part of the audience. If you enjoy this deep dive into the frequencies of space, please subscribe to the show. Hey, and leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.
Thanks for having me.